Hello everyone, and in this tutorial we will do a little exercise with a Spring Boot application. We'll try to host it on an AWS EC2 instance and try to play with some of the JMX options. So JMX is Java monitoring tools. It comes with Java, so there is no need for us to get an external library or to install something. So that is provided within Java. And to do this tutorial and an exercise, I have divided it into like 5 steps, and each has its own importance and role to play. So the first one would be we will concentrate on launching a very simple AWS EC2 instance. We will mostly try a free tier one, and while doing that we will expose 3 ports. So first port being 8050, that is for our HTTP traffic. Then we will expose a port called port number 2099 for JMX server to expose the mbeans. And then we will expose another port 2098 for RMI server, that is for us to remotely connect to this application, and that will help us there. The second part would be to create a really simple Spring Boot application. I'm gonna call it Hello JMX, and use SL4J for logging purposes because it comes default with Spring. And we will play around with the different log levels like info, debug, error, warn, and what's available within SL4J. And to try this out, we will create a simple Hello JMX endpoint showcasing logging capability. So hey, so when your Spring Boot application start, what are the default log levels which are available, and we will try to showcase that using a simple get endpoint. The third part of it would really be hosting this Hello JMX Spring Boot application on the EC2 instance with JMX server settings and RMI server settings. So while we are launching this application on EC2, we will make sure that we expose the correct ports, which is 2099 and 2098 for RMI servers, and I'll show you how we will do that. For the test purpose and the real usage purpose, we will try to connect to the JMX and RMI server of the Hello JMX Spring Boot application remotely with a tool like Visual VM. So I'm using Visual VM because it's free and open source and it's really easy to use. So you can either use that or there are other tools available also. And the final step would be to modify the log levels of the Hello JMX application at runtime. So using this tool Visual VM, and when we will do this, we would have already exposed JMX server and RMI server using 2099 and 2098 ports. So we should be able to connect and change the log levels at Java package level from like debug to warn to info, and come back to the normal state of the application. So we will try to achieve this in this tutorial. So let's get started. So let's proceed to the first step, which is launching an AWS EC2 instance. So I have already signed into my AWS account, and I went to the services tab, selected EC2, and I came to the EC2 console, selected launch instance, and I'm checking this free tier only. So we will only get the images which are free of cost to use. And let's get started. So I'm going to select the Amazon Linux, and it comes with Java 1.7. So we'll make sure when we make our Spring Boot application, so the versions are compatible. So let's select it, and we really just need micro or nano, and we're going to do this. Number of instances 1, so this is my default VPC. We don't need all these things. I'm just going to use the default settings here. Go to storage, again use the default settings. I really need no need to add tags here because I'm gonna kill this instance as soon as this tutorial is over. Security group. So this is where we have to configure all the ports we discuss about. So 8050, 2099 and 2098. So let's see how we're gonna do that. So SSH TCP is good, but I'm gonna restrict it to only my IP. Add a rule, and we're gonna use a custom TCP rule. Yes, and this is our first port 8050, and again this is only for my IP. Add another rule, 2099 my IP, and finally for the RMI server 2098 and my IP, and we'll say review and launch. So all these things looks good. We've exposed all the ports, and this is my IP we're going to use, and say launch. And I think in some previous exercises I've already used a key pair, so I have this on my machine. So I'm going to say, hey, you know what, go ahead and use Hitesh test key pair, and I'm going to say launch instance. So now my instance is getting launched. We're going to go here, the dashboard, and it's now launching. And from once it is launched, we will use some of the information to configure our Spring Boot application, because we will need some of those key information from this launched EC2 instance. So I'm going to pause this here and wait for the instance to come up, and we'll continue from there. Welcome back. So now we have this EC2 instance up and running, and some of the information we will need is the public DNS, because we have to use this as the host name when we configure the RMI server within our Spring Boot application. So let's see what was the next step for us. So the next step is to create a simple Spring Boot application, and we're going to call it Hello JMX, and we will use SL4 and all those things. So let's do that. Okay, so I'm using Eclipse, and I do have Eclipse STS plugin installed on this. So I'm going to use the new Spring Boot app, project wizard to get this started. So Spring Starter project, and we're going to call this Hello JMX EC2, and we're going to use Gradle STS, and remember we're going to use 1.7, and call it Hello JMX, and the same name we're going to use it for demo, and my package name. So let's select some of the dependencies and capabilities we need. So web services, and that's all. So next, and we're gonna say, hey, yeah, create me a Spring Boot application. Okay, so now we have a nicely configured Spring Boot application, and we have our main application class here. Good. So let's see what we have next in our to-do list. So SL4J, that is already configured, and another one is create a simple Hello JMX endpoint showcasing logging capabilities. So let's do that, and we create another class here. Call it Hello JMX controller. Very well. So @rest controller. Very good. We're gonna create a request mapping here. And the value would be, hey, Hello JMX. Cool. And let's quickly create a logger instance. Get logger class, and you all see now we have already imported the SL4J, which comes default. So here we go, dot class. and log.sl4j. So now we have a logger instance available for us to use in an application. So public string hello JMX, and this could be request mapping, and method be request method, it's going to be get. Cool. And so now we'll just put a small logic here. I have already done it on another of my classes. I'm just going to copy it from there and paste it here for convenience of this tutorial. So this is what we are doing, right? So nothing big here, very simple. We created a string builder result, and if debug is enabled, that result is appended by a string. If warn is enabled, then again it is appended by another string, and all those things. And in the end, when we call this hello JMX application, it will return us back whatever the content of this result string is. So let me quickly try to run this application and see if it works. So SpringBoot app. Okay, so it is getting started, but the port is 8080. So I'm going to change a few of those properties using this. Let me rename it to YAML. I like YAML formatting. So, okay. So now we have application.yaml. I'm going to put some properties here. So, okay. So I've specified that port should be 8050 for the application to start itself. So again, I'm going to go to the application and run as SpringBoot app. Okay, so we have the application running at 8050 now. So if I go back to my browser and do localhost :8050 and hello JMX. Okay, it's not coming up. Let me see, what did I do here? Okay, so this is this and not that. Okay, so see, we started the Spring Boot application with default configuration, and let's see what all happened when we executed that controller. So we got warn, we got info, and we got error. So this means that Spring Boot started itself with SL4J properties or logging properties with these log levels enabled by default. But since the debug is not enabled, the string did not get appended with that statement which we used, and so it's not showing up. So debug level enabled is not part of my result back. So this is what we are going to do. So at runtime, you want to change the debug level, because you really don't want debug to be enabled all the time for your application, because it appends a lot of lines to your log file or to console, and you really don't want all that information available all the time for anybody. So it should be like on demand basis for a short period of time. You should be able to enable the debug, come back to the normal state, and that kind of fashion with the log levels. So let's see how we're going to do that. For the next part, we are going to do a little more configuration for the SL4J and logback properties. So within my resources, I'm going to create a new file called logback.xml, and this is the particular file name what SL4J and logbacks look for when it's trying to configure. So it's logback.xml, and then there is a key configuration within this log files which tells SL4J and logback to expose the mbeans for logging purposes, or the mbeans contained within SL4J and logback. So this is how it looks. So this particular lines gives the capability for the SL4J and logback to expose that particular mbeans for logging, which is already there. So once we have done that, let's get this application started once again and see if it picks up that, and we have a running application. Okay, so sorry, the last time I think I didn't kill the application, so that went wrong. So let's try to reboot it again. Alright, so again we were able to successfully start the application at 8050. Now we're going to do two things. First, we're going to try SSHing into the EC2 instance. So this is the command we're going to use, SSH, saying that hey, use my key pairs, and by default the instance we launched created a user called EC2 user, and this is really the public DNS provided by the AWS. So this is the value I picked up from here, public DNS IPv4, and let's try if we can get into this box. And yes, so we are into this box now, Amazon Linux AMI. Try to run some commands. So if you do pwd, it says hey, this is where you are. I'm going to do ls-ap, so all these files are there. So yeah, so now from my terminal I'm able to SSH into the EC2 instance. So that went well, means our security group worked. And the next step is we're gonna build the jar out of the code what we just did within the Eclipse and the Spring Boot while we were developing the Spring Boot application. So during the Spring Boot wizard we selected Gradle, so I'm gonna use Gradle for creating this jar. So Gradle clean build, and okay, so it start building, and when it completes we should be able to see a jar created, a deployable jar created for the Spring Boot application. So I know where it's going to be, build libs ls-ap here. I can see this jar. So the next step for us would be to take this jar from my local system to the EC2 instance. So let's get started and do that. So let's do a pwd here and see, okay, this is my path very well, and I'm gonna come out of this box and use scp to transfer this file to the box. So pwd, so this is the source, absolutely, and this is the file name, hello JMX snapshot.jar, and the destination is EC2 user, this box, and I'm just gonna do this to home of the EC2 user, so home of the EC2 user. So from my local I'm gonna copy this to this particular path, and let's see how that goes. So it's now copying, as you can see, it's transferring bytes, and we're almost there. Cool. So it was able to copy that, and I'm back here. So let's go back and SSH into the box and see if it really got copied or not. So this, and okay, SSH, very well. I'm gonna do ls-ap now, and now you see my hello JMX snapshot.jar got copied. Let me give it a shot and try to run this. Java -jar. Alright, so now Spring Boot is getting started, and let's see if it's gets started on the same port we described. Yes, it did. So now within the EC2 instance we are able to start this Spring Boot application. So far so good, and now we're gonna do some really interesting stuff to I'm gonna show you how you're gonna enable the JMX server and the RMI server on this EC2 instance, and later we will try to connect it remotely through a visual VM running on my local machine. So this time we're gonna again SSH into our EC2 box where we have the hello JMX application, and this time we will start the application with some really interesting arguments for JMX and RMI. So let's do that. So here we are, and if we see, we have our hello JMX Spring Boot application jar, And let me show you those options and how we're going to use them and what does each and everything means. So Java jar will help us run the jar, and then these are the options which will help us expose that RMX port 2099. For now, in simplicity, I have made use of the authentication is false. You can definitely make this feature true, and then there are additional settings which you have to do for username and password. SSL, you can use SSL, and then you have to configure your RMAP port, which will help you doing connection. And this is the setting I was talking about, which is the RMI server hostname, and we're going to use the public DNS hostname from the AWS. And using this entire command with these arguments, we're going to start the Hello JMX application again. So let me copy this here and go back to the EC2 console now here on my terminal window and do this. All right, so again, the application is starting. It's going to be very simple, nothing fancy or to notice here. And we see that, hey, it was able to register beans on the startup and it started on 8050. So the operational part of this tutorial is almost done. Now comes the testing part, or really what we achieved through this. So let's go to the browser and see if we can hit this SpringBoot application with the same endpoint, and let's see what results come. So now in place of localhost, I'm going to use this, go back up here and do this, and let's see what do we get out of it. All right, so we got the same result. Means the configuration on the local for the SpringBoot application and the configuration of the SpringBoot application on the EC2 is same. So we got the same result back: one, info, and error. So all these log levels were available by default even on the EC2 instance. And now comes the next part of the tutorial, where we will use the visual VM to connect to this remote Java application in form of SpringBoot and change some log levels and play with it. Okay, so this is my visual VM running on my local system, and right now we're gonna create a remote connection, or rather add a remote host first and then create a JMX connection. So your host name is nothing but your public DNS on the Amazon EC2, and here we're gonna modify the port to 2099 because that's the one we are using, and do this. Okay. So this just added a host. Now we need to add a JMX connection, and it already picked up your host name, and this is the port we're gonna use, and we're gonna say okay here. All right, okay. So now this JMX connection is established, and let's see what all we can do with it. So it got connected to the remote host, and we have all these things you can monitor using Visual VM and other monitoring stuff standard with Java. The one we are interested in is the mbeans part. So if you look at mbeans part, you see this package. This is the logback package, and this is which we're going to use. If you click on this particular mbean here, you see all these things and you see operations. And the one we are really interested in is the set logger level. And it takes two arguments. So the first one is usually the package name, and the second one is the log level which you want to use. So let's get back to Eclipse and see what was the package name we used, and we want to this time pass on the debug log level. So this is the package name we were using. Going back to Visual VM, putting this here, and the string as debug. And as soon as you press enter, it gives you, hey, method successfully invoked. So as per theory, now for this particular Java package, we have enabled debug. And if we go back to the code, now as part of the result string, we should be able to see debug level enabled. And let's test that out. So we go back to the browser. This is the EC2 host, and let's see. All right, so you can see that we were able to switch log levels to debug for this particular Java package on runtime. And this is how we use JMX and logback properties to accomplish this. So now all the debugs within this package will work in your real-time application, and you can go back and switch them back to normal mode. And let me quickly show you how do we do that. We go back to Visual VM and use this reload default configuration. So as soon as you do that, And if you go back to your endpoint or mostly test it out, now the debug level should be gone back to normal and we should only see warning for an error. So let's do that. Awesome. So now the application has switched back itself to a default log level and there is no debug anymore. So you can do this with various packages, and on need basis you can really work with your operation teams or DevOps structure in your organization to make use of this setup, and not that complex, but it comes in really handy. I hope you like this tutorial and you'll benefit in some or the other way out of this. Now, thank you so much for watching.